This is the second video of lesson 1.2, Solving Linear Equations. This lesson goes a little bit more in depth, but your I can statement and your learning target is still the same. Create and solve linear equations with just one variable. We are following along in our student companion. If you do not have yours yet, use a piece of paper. Write down example 1 that I've written bigger for you here in blue. We're going to use our order of operations, which I've written on our left-hand side where we take notes. Your order of operations of parentheses, exponents, multiplication, division, addition, subtraction. We're going to use those order of operations starting at the bottom with addition and subtraction and working our way backwards to solve this equation. When we are using our order of operations, we start looking for addition or subtraction first, and we undo that. I can see I have a couple pieces of addition or subtraction on the left-hand side of my equation. Remember, the equal sign divides our equation in half. The left-hand side, I have a 4 plus, and then I also have a 3x minus 1. So it looks like I have two things I could start to undo. And on the right-hand side, we just have the number 9. Well, this 3x minus 1 is a fraction. It is in its own world right now, and we cannot undo that minus 1 just yet because it is in the numerator of that fraction. But we can undo this positive 4, and I can use subtraction to undo positive 4. So I subtract 4 from both sides, and I am left with 3x minus 1 divided by 2 equals 5. Did you hear that? 3x minus 1 divided by 2. And that's because fractions are, and on the left-hand side where we take notes, fractions are division. They're just an operation. And we're just going to undo that operation. The opposite of division is multiplication. So we're going to undo that next. Right now, 3x minus 1 is being divided by 2, so the opposite is to multiply it by 2, and we do that to both sides. When we have a multiply by 2 and a divide by 2, those undo each other, and all we are left with is 3x minus 1 equals 10, because of 5 times 2 is 10. Now I can use my opposite operations to continue solving. I do my addition and subtraction first, now that I'm a basic two-step equation. I'll add 1 to both sides. I'll have 3x equals 11. 3 times x, when something's right next to each other, they're being multiplied. The opposite thing is to divide by the number in front of it. And when I actually go to divide 11 by 3, I get a decimal. So here's your pro tip for high school. Leave it as a fraction. Take this note with me. Do not round. We tend to make rounding mistakes, so we're just going to leave this as 11 over 3. And now there's no rounding mistakes. Look down at example 2, and we actually need to change some things. So we're going to take out the word odd, and we're going to change this number to be 132. Now we're ready to read the problem. It says, the sum, pause, what does sum mean? Add, means we're adding. The sum of 3 consecutive integers are just numbers, 3 consecutive numbers is 132. What are the 3 numbers? So this problem is telling us that there are 3 numbers in the world that are consecutive that add to be 132. We need to know what consecutive means. Consecutive means like in a row, one right after another. An example of 3 consecutive numbers could be 5, 6, and 7. Those are 3 consecutive numbers. Now, they do not add up to be 132, so they're not our answer, but they're an example of just 3 consecutive numbers. We want three numbers. Let's call them A, B, and C. That when we add them all together, we get 132. Some number A plus some number B plus some number C is 132. And we got to find out what those numbers are. The problem comes into we don't know how to solve an equation that has three variables and nothing else. So we need to relate all of these numbers back to one thing, and we're going to make that the first number. So if the first number in our list is A, just like the first number over here was 5, we need to talk about the next number in terms of the first. So that's going to be A plus, and now we're not going to write B because that's a whole new number. Let's think. If these are consecutive, they're in a row. So B is going to be the number that comes right after A. So essentially, that's just whatever A was plus 1. And that's what the next number will be. If we know the first number, then we can add 1 to it, and we can get the number right after it. Same with C. If we know the first number, A, we can add 2 to it, and we'll get the third number. Look at our example sequence, and you'll see that that's true. 6 is the same thing as 5 plus 1, and 7 is the same thing as 5 plus 2, starting with just that first number both times. Because now this is an equation that we can solve. We can combine our a's, they are like terms, and we have 3 of them, 3a. We can combine our constants, 1 and 2, to be 3. 3a plus 3 equals 132. And now we can use opposite operations to solve. Subtract 3, those add to be 0. We bring down the 3a, we end up with 3a equals 129. We can divide by 3 to undo that 3. And we end up with our first number, A, is 43. The first number, A, is 43. Well, now, let's read the question. It wants to know the three numbers in a row. Well, if the first number is 43, what's the number that comes after 43? 44. What comes after 44? 45. Those would be our three consecutive numbers. And we can double check this just to be sure. Is 43 plus 44 plus 45, does that equal 132? Yes. So we know we're right. Last example we're going to do together in your student companion is actually 2 pages over in the practice and problem solving number 23. It's a great example of distribution and combining like terms. So we are going to do that one. I want you to actually pause and attempt it first so you can come back and learn from your mistakes. All right, you've tried it. Let's see how you did. Was the first thing you noticed this distribution that you have to use multiplication for? 10 times 5 would be 50. 10 times the negative n would be negative 10n. We bring down that minus 1, and we bring down our equal sign of 29. Now, before we are ready to do some opposite operations, we got to simplify first. Let's see if we can combine any like terms. What about 50 minus 1? We can totally do that. 50 minus 1 is 49. And then we can still bring down that minus 10n equals 29. Now, let's do our opposite operations. I'm not ready to work with the variable yet because there's some addition or subtraction I can undo. I can undo that positive 49 to be negative 49 on both sides. Bring down my negative 10n. Negative 10n equals, now that is 29 minus 49, and that is negative 20. Then I can divide by -10, that's the number in front of our variable, and n equals 2. That was a negative divided by a negative. Just another example of solving equations that has some distribution as its first step and some combining like terms. Rewind and watch as needed.